Today we are going through important questions from continuity and differentiability, that is previous year's questions. First question, find the value of a for which the function defined as f of x is equal to a sin pi by 2 x plus 1 when x less than or equal to 0, tan x minus sin x divided by x cube when x greater than 0 is continuous at x is equal to 0. Very, very important question. So you should practice with these problems. Okay. So here we have to find the value of a when this function is continuous at x is equal to 0. What is the continuity function? That is continuous function when a function is continuous. So here we know that according to the definition of the continuity, limit here at x is equal to 0, right? So the given function is continuous at x is equal to 0 means limit x tends to 0 minus f of x, that is equal to limit x tends to 0 plus f of x, that is equal to f of 0, value of the function. It is the definition of the continuous function, right? So here we will equate these things, then we will get the value of a. Okay, so here let's find limit x tends to 0 minus f of x. We know x tends to 0 minus means x approaches to 0, very close to 0, but it is less than 0. Okay, not equal to 0, it is close to 0 and less than 0. Okay, now let's find left hand limit. Limit x tends to 0 minus f of x, that is equal to limit x tends to 0 minus, here when x less than 0, the function is a sin pi by 2 into x plus 1, right? Limit x tends to 0 minus a sin pi by 2 x plus 1. Why? Because when x less than 0, it is given function defined as when x less than 0, f of x is equal to a into sin pi by 2 into x plus 1. Okay, now see in limit question, in limit problems, first of all we will apply substitution method, means we will substitute the values, right? Okay, so we will substitute. After substituting, the value is undefined, then we have to apply another method, okay, some other method. So here, see, before doing continuity problems, see, first of all you have to write all the standard limits, okay, standard limits equations, then study it well, then come to continuity problems. Okay, so here limit, let's substitute x is equal to 0. Okay, so when we substitute x is equal to 0, a is constant, a into sin pi by 2 into 0 plus 1. 0 plus 1 is 1, right? So sin pi by 2 into 1, that is nothing but sin pi by 2. Okay, so what is sin pi by 2? Sin pi by 2 value is 1. Okay, so a into 1, that is a. We have got limit, left hand limit is a, okay, value of left hand limit a. Now next we will find right hand limit, that is limit x tends to 0 plus f of x. That is when limit x tends to 0 plus means it is very close to 0 but greater than 0. Okay, so when x is greater than 0, the function is tan x minus sin x divided by x cube. Okay, so here first of all we will apply substitution method. Substitute what is the value of x. Okay, so x 0 plus. Okay, so substitute x is equal to 0. What you will get? Tan 0 minus sin 0. Okay, leave it. So in denominator you will get 0. That means it is undefined. Okay, you will get 0 by 0 form, or in denominator 0 means it is not defined, right? So here in this case we have to apply other methods. Okay, so for that we have to simplify. See here it is equal to, let's simplify. What is tan x? Tan x is nothing but limit x tends to 0 plus tan x can be written as sin x divided by cos x minus sin x divided by x cube. Okay, then see, when you solving this problem, see it should have in your mind, that is here what is our limit, standard limits. We know that limit x tends to 0, sin x divided by x is equal to 1. Okay, limit x tends to 0, sin x divided by x is equal to 1. So according to that we will simplify this one. Okay, now see here sin x is common in both terms. Let's take it out, or first of all let's take LCM. Okay, so limit x tends to 0, sin x minus sin x cos x divided by x cube into this cos x will be in denominator. Okay, cos x. Okay, then here, then take sin x outside. Limit x tends to 0 plus sin x into 1 minus cos x divided by x cube into cos x. Okay, then here, okay, then let's separate it. Okay, that is equal to, we have limit x tends to 0, sin x divided by x is equal to 1. See here we can write it as limit x tends to 0 plus sin x divided by x. Okay, denominator remaining. Okay, so I will write 1 minus cos x divided by x square. Okay, into 1 by cos x. Okay, sin x divided by x. Okay, x cube is x into x square, right? So sin x by x, so that we can apply this standard limit, right? Okay, sin x by x into here this 1 minus cos x divided by remaining x square into 1 by cos x. Here 1 by cos x we can apply the limit substitution method, right? See, when we put x is equal to 0, we will get 1 by cos 0. Cos 0 is 1, so 1 by 1 we will get 1. Okay, and here we have to simplify. Okay, here 1 minus cos x, we have this standard limit. Okay, so how can we write 1 minus cos x in sine terms? See here, we know that 1 minus cos 2x is equal to 2 sine square x, right? Okay, we have an identity, 1 minus cos 2x is equal to 2 sine square x. Here we have only cos x, right? So 1 minus cos x is equal to 2 sine square x by 2. 2 sine square x by 2. So we will write it here. Okay, that is limit. Here we can multiply the limit. Okay, we know that limit of f of x into g of x into h of x, that is equal to limit f of x into limit g of x into limit h of x. Okay, algebra of limits, we have already learnt it. That is limit x tends to a, f of x into g of x into h of x, that is equal to limit x tends to a, f of x into limit x tends to a, g of x into limit x tends to a, h of x. Okay, we can apply this one here. Directly we can write limit x tends to 0 plus sin x divided by x into limit x tends to 0 plus 1 minus cos x can be written as 2 sine square x by 2. 2 sine square x by 2 divided by x square. Okay, into limit x tends to 0 plus 1 by cos x. Okay, see here, remember we have standard limit. Limit x tends to 0, sin x by x is equal to 1. Okay, we have to make it in that form. Okay, so next step is, that is equal to limit x tends to 0 plus f of x. It is right hand limit. Okay, limit x tends to 0 plus sin x by x is nothing but 1. Okay, 1 into, and here let's make it in the form of limit x tends to 0 sin x by x. Here we have this standard limit, limit x tends to 0, sin x by x is equal to 1. Then limit x tends to 0, sin square x by x square is equal to 1. Right? That is limit x tends to 0, sin raised to n x divided by x raised to n, that is also equal to 1. Okay. So here it is sin square and it is not x by 2. Okay. So here we have to make in the denominator x by 2. Okay. So x by 2 whole square. Right. So here we will multiply. Okay. 2 sin square x by 2 divided by, we will make it x by 2 whole square. X square is there, right? So x by 2 whole square means we have here multiplied 1 by 4, right? Multiplied 1 by 4. So here we will multiply 1 by 4. Okay? In denominator we have multiplied 1 by 4. So we have to multiply 1 by 4 in numerator. Okay? Into here, limit x tends to 0, 1 by cos x. Cos applied x is equal to 0, substitute x is equal to 0, 1 by cos 0, 1, that is 1. Okay, now what about this one? Here 2, this 4 will be down, okay? Sin square x by 2, x by 2 whole square, that is equal to, here it is 1 by 2 and I forgot to write the limit, okay? Limit x tends to 0 plus, okay, that is equal to, here 1 by 2 into limit x tends to 0 plus sin square x by 2 divided by x by 2 whole square, that is equal to, see, it is nothing but it is in the standard limit, okay? So it is the standard limits and its value is 1, okay? Therefore limit x tends to 0 plus sin square x by 2 divided by x by 2 whole square is 1 by 2. Okay, then here we have got right hand limit is 1 by 2 and left hand limit is a, right? Limit x tends to 0 minus f of x, that we have got a, right? So here it is given that this function is continuous at x is equal to 0, therefore left hand should be equal to right hand limit, right? Left hand limit is equal to right hand limit. Therefore, a is equal to 1 by 2. Okay. Since f of x is continuous at x is equal to 0, limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x. Okay. That implies a is equal to 1 by 2. So what is the value of a? A is equal to 1 by 2. Look at the second question. Find the value of k so that the function f defined by f of x is equal to k cos x divided by pi minus 2x if x not equal to pi by 2. F of x is equal to 5 if x is equal to pi by 2 is continuous at x is equal to pi by 2. It's very important question. And here the function, it is given that function is continuous at x is equal to pi by 2, then what is the value of k? Okay. So here according to the definition of the continuity, we know that left hand limit, that is limit x tends to pi by 2 minus f of x, that is equal to right hand limit, that is equal to value of the function, right? Limit x tends to pi by 2 minus f of x, that is equal to limit x tends to pi by 2 plus f of x, that is equal to value of the function, that is f of pi by 2. Okay, and it is given that the function is defined by f of x is equal to this one, that is k cos x divided by pi minus 2x if x not equal to pi by 2. That means for x less than pi by 2 and x greater than pi by 2, the function is same, that is k cos x divided by pi minus 2x. And if x is equal to pi by 2, the function is 5. That means f of pi by 2 is 5. Okay. So here f of pi by 2 is equal to 5. Okay. Then now we can find any one of these. Pi by 2 minus pi by 2 plus, because the function is the same, right? So let's find this one and equate to this value of the function so that we will get the value of k. Okay. Then let's find limit x tends to pi by 2 plus f of x. That is equal to limit x tends to pi by 2 plus f of x is k cos x divided by pi minus 2x. Okay, and we know that in limits problem, first of all we will substitute the values, right? If x tends to pi by 2, we will put x is equal to pi by 2. Okay, but here substitute x is equal to pi by 2. What you will get? See, we will get 0 in denominator, that is undefined, right? It is not defined. So therefore, we have to apply some other method. Okay, see, if you put pi by 2, pi minus 2 into pi by 2, 2 cancelled, you will get pi minus pi, that is 0. So 0 in denominator. So here we have to apply some other method to find the limit. Okay, so here we know that x tends to pi by 2 plus. X tends to pi by 2 plus means the value of x is very close to pi by 2 and it is greater than pi by 2. That means x is equal to pi by 2 plus a small value. So here we put x is equal to pi by 2 plus h. H is a very small value. Okay. Then here x is equal to pi by 2 plus h. And when we change the value of x, these limits will be changed. Okay. So here when x tends to pi by 2, that implies h tends to 0. How? Put x is equal to pi by 2. So pi by 2, take this pi by 2 here, you will get h is equal to 0. Okay. That means when x tends to pi by 2, h tends to 0. Okay. So this limit will become limit h tends to 0 k cos x divided by, not x, we have put x is equal to pi by 2 plus h. Pi by 2 plus h. We can write this k outside of limit because k is a constant, right? Divided by pi minus 2 into pi by 2 plus h. That is equal to, okay, here k into limit h tends to 0. Here, what is cos pi by 2 plus h? See, we have already learnt in our trigonometric functions sin pi by 2 minus theta cos pi by 2 minus theta sin theta, right? Cos pi by 2 plus theta is minus sin theta, right? Why? Because here pi by 2 plus theta means it lies in second quadrant, right? 0, pi by 2, pi, 3 pi by 2, right? Pi by 2 minus theta, it lies in first quadrant, and in first quadrant all are positive, and in second quadrant pi by 2 plus theta, it lies in second quadrant. In second quadrant, only sine and cosec are positive and remaining are negative, right? So here cos is negative. Therefore, cos pi by 2 plus h is nothing but minus sine theta. Okay, that is cos pi by 2 plus theta is minus sine theta. So cos pi by 2 plus h is minus sine h. Divided by, here after simplification, pi minus multiply this 2 pi by 2 minus multiply minus into plus minus 2h. So here 2 cancelled, so it will get pi minus pi is 0, so remaining only minus 2h. Okay, so here minus cancelled, that is k, 1 by 2 is constant, take it out, k by 2 into limit h tends to 0 sin h divided by h. What is sin h divided by h? Limit h tends to 0 sin h by h is 1. That is, we have a standard limit x tends to 0 sin x divided by x is equal to 1. That is why I said, see, you have to study limits very well and come to do these problems, okay, solve these problems, okay. So here k by 2 limit h tends to 0 sin h by h, that is equal to k by 2 into 1, that is k by 2. So we have got right hand limit is k by 2 and value of the function is 5. Since it is continuous at x is equal to pi by 2, here k by 2 is equal to 5. right? Means right hand limit that should be is equal to value of the function, right? Because it is given this function is continuous at x is equal to pi by 2. Therefore, right hand limit that is k by 2 that is equal to value of the function. So this implies k is equal to 2 into 5, 10. The value of k is 10. Next question is, show that the function f of x is equal to modulus x minus 3, x belongs to R, is continuous but not differentiable at x is equal to 3. So here, okay, first of all, let's prove it's a continuous function. So for that, here also, first of all, we will define the function, that is f of x is equal to modulus of x minus 3. It can be redefined as f of x is equal to, we know that modulus x can be defined as minus x if x less than 0 and modulus x is equal to x if x greater than 0, right? So in the same way, f of x is equal to modulus x minus 3. So minus of x minus 3 when if x minus 3 less than 0 and plus x minus 3 when x minus 3 greater than or equal to 0. That is, minus of x minus 3 means 3 minus x, right? 3 minus x when x less than 3. Take minus 3 here. So x less than 3 and x minus 3 if x greater than or equal to 3. Okay. Now here, let's find left hand limit, right hand limit and the value of the function at x is equal to 3. So limit x tends to 3 minus f of x, that is equal to, here 3 minus means left hand limit, that is x less than 3. So when x less than 3, the function is 3 minus x. Limit x tends to 3 minus x. Now let's put x is equal to 3, what you will get? 0, right? Then next we will find right hand limit. Limit x tends to 3 plus f of x, that is equal to limit x tends to 3 plus f of x is when x greater than 3, f of x is x minus 3. So here also substitute x is equal to 3, we will get 0. Okay. Next we will find f of 3, that is value of the function. When x is equal to 3, see here, when x is equal to 3, the function is x minus 3. Okay, that is f of x is equal to x minus 3. f of x is equal to x minus 3. So what is f of 3? Substitute x is equal to 3. So 3 minus 3, that is 0. So here we have got limit, left hand limit, right hand, that is equal to right hand limit, that is equal to value of the function. Therefore, given function is continuous at x is equal to 3. Okay. So f of x is continuous at x is equal to 3. Okay. Now next we have to prove it is not differentiable at x is equal to 3. Next we will prove it is not differentiable at x is equal to 3. Okay, given function is f of x is equal to modulus of x minus 3. And we know that a function is differentiable at x is equal to c if f dash of c is equal to limit h tends to 0. Sorry, h tends to c, f of c plus h minus f of c divided by h exists. Or left hand derivative that is equal to right hand derivative. Okay, then we say given function is continuous at x is equal to a particular point. Okay, so here we have to prove it is not differentiable at x is equal to 3. Okay, so here c is equal to 3. Now let us take left hand derivative, that is f dash of 3, that is equal to limit h tends to 3 f of c minus h. Left hand derivative is f of c minus, that is 3 minus h minus f of 3 divided by h, that is equal to, here limit h tends to 3, What is f of 3 minus h? F of x is x minus 3. So f of 3 minus h is, substitute x is equal to 3 minus h. So that is 3 minus h minus 3. So 3 cancelled. That is modulus of minus h, that is equal to, okay, modulus of minus h minus f of 3. F of 3 is 0, right? Modulus of 3 minus 3, that is 0, divided by h. It is minus h, sorry, minus h, okay? Left hand derivative is f of c minus h divide f of c minus h minus f of c divided by minus h, okay? It is minus h. That is equal to, here modulus of minus h is h divided by minus h, that is equal to minus 1. And right hand derivative f dash of 3, that is equal to limit h tends to 3 f of 3 plus h, okay? Right hand derivative f of c plus h minus f of c divided by h minus f of 3 divided by h, that is equal to limit h tends to 3 f of 3 plus h is, substitute x is equal to 3 plus h, 3 plus h minus 3, that is equal to 3 cancelled, modulus of h. So modulus of h minus f of 3 is 0 divided by h. So here modulus of h is nothing but h itself. So h by h, that is equal to 1. Okay. So here we have got right hand derivative is minus 1 and left hand derivative is minus 1 and right hand derivative is 1. That means here it is not equal, right? They are not equal. Therefore, the the function derivative does not exist at x is equal to 3. Therefore, this function is not differentiable at x is equal to 3. So here left hand derivative not equal to right hand derivative at x is equal to 3. Hence, f of x is not differentiable at x is equal to 3. Okay. Next question. If f of x is equal to x square minus 25 divided by x minus 5 if x not equal to 5 and f of x is equal to k if x is equal to 5 is continuous at x is equal to 5, then find the value of k. Okay, so here it is given, the given function is continuous at x is equal to 5, we have to find the value of k. Since it is continuous at x is equal to 5, so the limit, that is left hand limit, that is equal to right hand limit, that is equal to value of the function. What is the value of the function? That is nothing but k. F of 5 is equal to k. Okay, so here we can write, since f is continuous at x is equal to 5, limit x tends to 5 minus f of x, that is equal to limit x tends to 5 plus f of x, that is equal to f of 5. So here f of 5 we can write directly, that is f of 5 is equal to k. Right? Value of the function, that is equal to k. Now we can, it is enough to find any one of these, right? That is limit x tends to 5 minus, because here it is given if x not equal to 5, the function is this one. That is, for x less than 5 and x greater than 5, the function is x square minus 25 divided by x minus 5. So here we will find limit x tends to 5 minus f of x, okay, any one of this. That is equal to limit x tends to 5 minus f of x is x square minus 25 divided by x minus 5. That is, here, see, first of all we will apply substitution method, that is substitute x is equal to 5. If we substitute x is equal to 5, we will get 0 in denominator, that is not defined. Therefore, we will simplify this one. Here, see, x square minus 25 can be written as x plus 5 into x minus 5. That is a plus b into a minus b form. It is in the form of a square minus b square, right? So, a square minus b square is nothing but a plus b into a minus b. So, this can be written as limit x tends to 5 minus x plus 5 into x minus 5 divided by x minus 5. So that this x minus 5 cancelled. Okay. Now we can substitute directly. Okay. If we substitute x is equal to 5, we will get the limit is 10. So substitute x is equal to 5. So 5 plus 5, that is equal to 10. So here we have got left hand limit is equal to 10, and you will get right hand limit also, that is equal to 10. And since it is continuous at x is equal to 5, this left hand limit, that is equal to value of the function. So here we can write limit x tends to 5 minus f of x, that is equal to f of y. That implies, because it is given this function is continuous at x is equal to 5. That means according to the definition of the continuity, left hand limit, that is equal to right hand limit, that is equal to value of the function. Right? That means here we have found left hand limit, right? So we can equate this left hand limit equal to with this value of this function. So that is limit x tends to 5 minus f of x is equal to f of 5. That implies, what is f of 5? K, right? K is equal to 10. That's all. Value of k is 10 because f of 5 is equal to k and limit x tends to 5 minus f of x is equal to 10. Therefore, k is equal to 10. Value of k is 10.